This friend up here, of course, we all know as a circle. One of the small problems about having a circle, though, is it's very difficult to actually do anything measuring with it. Because as you may have possibly gathered with our ruler friend, I can't really measure anything with it. Well, I can measure a few things, and some ancient Greeks did a lot of work for us quite a while ago. There's a few things we can measure, but it's worthwhile knowing a few things about circles in order to do so. So one of the things that we have is the little measurement going right through. If I was to measure right through the center, so making sure I measure right through the center, that's a thing that we call the diameter. So there's our diameter. Now, the diameter can be going, it doesn't have to be a horizontal line. The diameter could be like that, or like this. It literally does not matter, as long as it goes right through the center. Fun fact, if it doesn't go through the center, the line is called a chord. So the other thing is also that we also need to know is that halfway of that diameter is called the radius. So there we go. And again, the radius can be any point as long as it's from the center of the circle to the edge. So the radius is also here as well. There it is. So that's also fine. How is this vaguely useful? Well, the wonderful thing about when we're trying to work out measurements, we've discovered this thing called a ruler, and we're absolutely obsessed with it. Well, how can we use this to measure out stuff? Well, one thing it is very good at is measuring string. So what I've done, you can see here, so I've measured bits of string. Now what I'm going to do is I'm going to use this to help me out measuring around the circle. Now, of course, I could have just used a whole string and just cut it off at the end, but some circles are far too big to have a big ball of string around. So I wonder if there is some possible way that I can compare it to the diameter. So what I'm going to do is I'm going to take some string, move it around the circle. How many diameters fit around the circle? And what we'll find, once I've got all this business, so now you might notice that I've got a little bit left over. Well, funny enough, this is where you might have heard of a little thing that we call pi. Pi is a number that's basically, if I round it up, it's got an infinite number of places. It's what's called an irrational number. And basically what the whole thing that we've discovered about pi is that the diameter of a circle can fit around the circle 3 and a bit times. That's basically where this pi came from. And once we discovered this, well, when I say we, I didn't really discover it at all. I basically used somebody else's work. But once some very important people from a very long time ago discovered what this magical number, then basically they did almost everything with it. So in order to find the distance around, the perimeter outside, which we've decided to call a circumference, the circumference they discovered was 3 and a bit times this diameter. And what we tend to use, we tend to describe the circumference, is that we're actually saying, well, since a diameter is double the radius, because radius is halfway, we actually say that it's 2 times the radius times pi, or sometimes 2 times pi times r. So, or 2 pi r, sometimes we refer to it as. And that will find the distance on the outside. But why? Why not just use diameter? Why are we using this radius? Well, that's when it comes down to area. So I've got just the radius here. So I want to work out the area. Now, all the previous types, such as finding area of rectangles, would do the length and the width and multiply them together, or just use little squares. A little bit harder this time. So what I'm going to do is I'm going to use the guessing method like we were doing before. But this time I'm using big old squares. How big? Well, these are, each side is the same size as the radius. 1, 2, 3, Now you'll notice as I've added these squares on here that there's obviously some overhang. Well, would you believe that if I was to cut these sides off, it will fill up the other quarter? Yes, this means that the actual, and we usually have a little gap left over. Yes, in other words, it takes 3 and a bit squares, the size of the radius, to actually fill this in. Now obviously my little cutout there's a little bit dodgy, but basically what I've done there is I've cut off the edges and tried to stick and cut them out to stick there. And essentially what we've got, we managed to fit 3, more or less, and there's a little bit left over. So, each of those squares that I used, they were the size of, each side was side of the radius. So that was the radius there, and that was the radius there. The area of a square, this is a square, is equal to length times length, or length squared. So this was radius times the radius, which is radius squared. There are 3 and a bit squares that fit inside that circle. So the area of a circle is equal to 3 and a bit, or pi times radius squared. So that's where the area of a circle comes from, pi r squared.